I would like to talk about it. First of all, I'm very glad for the initiative that that Poetic Technologies has taken, and it is very admirable to take on such a task in such a complex industry as hardware. And there is a specific need for it as well, in my opinion, because a lot of the security primitives that we use today are derived from these Ts that are developed by closed source companies. And the root of trust in which almost all of the world places their trust in financial transactions with their personal data. All of this is very vulnerable to being exploited by just slightest attacks. So yeah, and just a bit of introduction for me. I have a background in hardware architecture. I've been researching and developing computer architecture and doing studies around performance architecture, doing security analysis attacks, and just mainly looking at characteristics of what computer architecture is on a granular level. And close to 5 years, I was working at NVIDIA for the up until July of this year, and so it's great to hear about the open source community take into their hands this challenge, which has generally been tackled by like the very big giants of the hardware industry. And I would take this opportunity to provide some perspective on how the companies that execute these things today approach these problems. So, within the ecosystem of closed source companies that are developing these solutions, I think it is very important to note that it's not the fact that it's they are malicious in intent from the nature, but the economic forces that drive innovation for such setups is that they only tend to focus on attacks which can be proven to be deployed. So internally, a lot of these companies, what they do is that they try to analyze their threat models and see what kind of attacks are deployable on a large scale, which can affect a huge user base or like large customers. But that approach has problems in like what multiple open source works have pointed out is that they tend to exclude some things which are not as pressing as at that scale, but still, nevertheless, those are important. Like for example, they don't include like robust security for side channel attacks. They don't implicate that these chips are going to be secure from any kind of physical attacks. So these incentives are what we are trying to focus on. And the overall challenge, I feel like, is very huge. And what we should try, the focus should be on becoming a value add in the industry. So a lot of the open source talk that I've seen about these is that we need to derive trust from verifiable compute. We need to implement technologies which can be verified from end to end. And although that, in my opinion, is an achievable goal, but what we need to figure out is that how to take some steps towards this direction. So, uh, like building tooling regarding open source technologies, like what Celine presented in terms of using the existing hardware and building primitives around it, which can derive trust other than the root of trust that these companies have designed. That is very important. And also, like it is also important to understand that these are just not a source of secure secured keys storage, right? Or it is just not an attestation machine. The concept of these can be used heavily in other industries also, like identification systems. It can be used to like verify compute, which is now being explored. So the opportunity that the big companies are leaving on the table because they are focusing on their economic incentives gives us a very strong, a very large playing field in terms of what is actually doable today. And I think the work is moving in that direction. Um, I would also like to introduce a little bit about the project that I'm working on with my team right now as well. So what we're trying to do is that one of the applications that we realized of that can come with secure computation is that the telecommunication networks or the communication that you do with other people, be it internet or normal telecommunication networks, those also involve personal data exchange. Those also need privacy and security. And what we're trying to build is that we're trying to build security system that lives on your device, leverages the separate coprocessor on your devices, which is called eUICC module. Uh, Leverages that to create a decentralized identity, to use that as as root of trust with the ZKPs to secure your identity and your data over telecommunication networks. So yeah, that's what we're trying to do. And again, I very happy for the opportunity to talk. And yeah, great initiative with Poetic Intents. I would love to hear, I would love to explore how this space goes on forward.